Hello my friends, today we are going to discuss about air refrigeration working on reverse Carnot cycle. And first we will discuss the pressure volume diagram, temperature entropy diagram, and we will discuss different processes involved in reverse Carnot cycle. And the final part is to derive the coefficient of performance of reverse Carnot cycle. So let us discuss about the pressure volume diagram first. This one is the pressure volume diagram of reverse Carnot cycle, and basically it consists of two isentropic process and two isothermal process, and 1 to 2, that is isentropic compression, and 2 to 3, it is isothermal compression. 3 to 4, it is isentropic expansion, and 4 to 1, it is isothermal expansion. Here this one is the temperature entropy diagram, and 1 to 2 isentropic compression, and 2 to 3 isothermal compression, 3 to 4 isentropic expansion, and 4 to 1 isothermal expansion. So the first one is 1 to 2, that is isentropic compression. Normally it is done through the compressor, and volume V1 to V2, the volume is decreased. It is a compression process, that definitely volume decreased from V1 to V2 according to a pressure volume diagram, and temperature increases from T1 to T2, and the pressure also increases from P1 to P2, and there is no heat addition or rejection through the process. The second one is isothermal compression. 2 to 3 process is isothermal compression. There is temperature remains same. T2 is equal to T3, but the volume decreased from V2 to V3. So V3 is less volume compared to V2, and pressure also increased from P2 to P3, and there is some amount of heat rejected, or the heat rejected, that is temperature into change in entropy. So change in entropy is S2 minus S3. S2 is the higher temperature, higher entropy, and S3 is the lower side entropy. The difference of entropy into the temperature, that is the heat rejected through the reverse Carnot cycle, particularly the isothermal compression takes place in the condenser. The next process is isentropic expansion. The 3 to 4 process is isentropic expansion, where entropy is constant. S3 is equal to S4. In that case, the pressure is decreases from P3 to P4, and the temperature also decreases from T3 to T4, and volume increases from V3 to V4. and also as it is isentropic process, there is no heat addition or rejection. And the next process is isothermal expansion. 4 to 1 as shown in PV and TS diagram. The 4 to 1 process is isothermal expansion, and it is done through the evaporator. The device is known as evaporator, where the actual heat is taken, or we can say the refrigerating effect is produced. In this process, the 4 to 1, the temperature is constant. T4 is equal to T1 as it is isothermal process. But volume increases from V4 to V1, and pressure also decreases from P4 to P1. The pressure decreases from P4 to P1, and heat is absorbed or refrigerating effect produced, that is T4 into S2 minus S3, the difference of entropy into the lower side temperature T4, or same as T1 into S2 minus S4, as T4 is equal to T1. So mathematically, if we calculate, then what we got, the heat absorbed equal to T4 into S2 minus S3, or equal to T1 into S2 minus S3. Heat rejected, so heat rejected is temperature, higher side temperature T2 into S2 minus S3, or equal to T3 into S2 minus S3. So the work done equal to heat rejected minus heat absorbed. What quantity of heat rejected to the condenser minus the quantity of heat absorbed or refrigerating effect produced by the refrigerator. So heat rejected minus heat absorbed. So finally, the work done is T2 into S2 minus S3 minus whole minus T1 into S2 minus S3. The coefficient of performance of a refrigerator working on reverse Carnot cycle, it is the ratio of heat absorbed to the work done. So heat absorbed by work done, and in a heat absorbed part, it is T1 into S2 minus S3, and in work done, it is T2 into S2 minus S3 whole minus T1 into S2 minus S3. And both S2 minus S3 is common, both the cases for numerator and denominator. Finally, the coefficient of performance of a refrigerator T1 by T2 minus T1. So thank you, Dost. Next we will see for the next video.